All right, so today we're looking at trigonometric ratios, particularly sine, cosine, tan, and we want to look at problems involving these. So I'm going to look at each one individually. We'd look at different ways we could manipulate the formulas for each of them and how to recognize the steps that I would usually use when we're going to apply one of these ratios, right? So to begin with, our sine ratio, the formula for the sine ratio is sine theta is equal to opposite over hypotenuse, right? Now, there are three variables in this formula. In order to use this, we need to know two out of the three. And any two could work. So we could have a scenario one where we want to find the angle, and we have the length of opposites. These are different color. And hypotenuse. Right? So to use this to find our angle, the angle in this case is theta, we need to know the length of the opposite and the length of the hypotenuse. Right? Three variables, you need two at all times in order to find one missing. This is the easiest or basic scenario, and you'll find anytime we are finding the angle, we will need to use what we call sine inverse. And I'll explain what I mean shortly. Right? Anytime we find the angle, we're going to need to use sine inverse. So let's get our other diagram going, right? So let's say we have a triangle. This is my triangle I'm going to draw here. Now remember, we are finding the acute angle in the right angle triangle. So this is my right angle triangle. Let's say I want to find this angle here. This is the triangle A, B, C, right? We have the length of the hypotenuse. Let's say the hypotenuse is 15 centimeters. And let's just say we are putting all of these just so that we can get a recap on identifying a size. So we have a triangle and they want us to find the size of angle ACB. So the one in the middle with this little hat on top of it is the angle that we want to find, this angle here. Now, your first step in doing this, step one, is always to label your triangle. Right? Just a second. Yeah, have you changed the travel? Right. Always label the triangle. So, sorry about that. The line away from this acute angle that we're trying to find, angle ABC, if we draw an arrow away from it, the side that is opposite it is our opposite. If we draw an arrow away from our 90-degree angle, the side that's opposite the 90-degree angle is called the hypotenuse. And then that would leave the bottom line here that is next to the angle being our adjacent. So we identify the different sides in a triangle. The next step, although I tell you what we're going to find already, is to list what we must find and what we have. For the sake of this part, I'm going to remove this 4 centimeters from here, right? Because we're using specifically sine. So I have my opposite, which is AB, and the length of which is 7 centimeters. I have my hypotenuse, which is AC. The length of that is 15 centimeters. And what must I find? I must find the angle ACB, which we said is theta. So we're looking at what we have. We have opposite, we have hypotenuse. At this point, I will write, although we know we're going to use sine here, right? I'm just showing you how to do it generally. If you don't know that I said we're going to be using sine. So usually what we will do is we'll write out our 3 formulas. SOHCAHTOA is what we'll use to remember sine, cosine, and tan. And we are looking for one of these formulas that have both O and H in it. Sine has O and H. Cosine has only H, so we can't use cosine. Tan only has O, so we can't use tan. So this is how you select which one of the ratios you're going to use, right? Because in our exam question, they're not going to tell you to use sine. You have to determine whether to use sine, cosine, or tan, right? So you choose the appropriate ratio based on what you have, and most importantly, sometimes what you have to find, right? So we're going to use the sine ratio. And the formula, that's my next step, put a formula. Will be sine theta, which is the angle, is equal to opposite over hypotenuse. Step 4, we're going to substitute our known values. So I do not know what the angle is. That's what I'm trying to find. The opposite is 7 and the hypotenuse 15. So I have to put in those values, 7 over 15. And now we're going to step 5, solve. Now we know, let's say in algebra, if we find in, say 2x is equal to 6, you will move this 2 across here. That's what we would say, right? And you'll divide 6 by 2 and you'll get 3. You want to do something similar. The thing is that if I move the sign, because I want to get theta, I want theta is equal to some particular angle in degrees. That's what I want to achieve. So it means that this sign needs to move across here on this side, right? But the thing about sine is that we do divide. When we move the sign across the equal sign, the sign becomes sine inverse of 7 over 15. So I just want to add something to the screen here. A second. To change my screen share. So sharing the entire screen because I want you all to see how you plug in this into a calculator. So we're looking at working out this here. Right? That's what we're looking at working out. So on the calculator, we will hit second function. This is going to allow us to access all of these functions written in orange to the top of these buttons. This is sine. So if I hit second function and press sine, I get the sine inverse, looking just like what I have on my page. Then I'm going to open brackets. And 7 over 15, you could write it as a fraction using this fraction button. Or 7 divided by 15 works the same way as well. Close brackets. I need to put that 7 over 15 in brackets so the calculator knows to divide that first and then find sine inverse of it. So this is what you're going to be punching onto your calculator. After you punch that onto your calculator, you hit equal, and this is your answer. Usually for degrees, we will always write a 1 decimal place. So the answer here is going to be 27.8 degrees. Yeah, everybody okay with that? And this is the first of our scenarios where we are finding for the angle. So here, this is finding the angle. Yeah? So we're going to our next scenario now. Scenario 2. So it's 3 scenarios for each one of these formulas, right? We're going to find a side. And in this case, we're using the sine formula, so we're going to find the opposite. All right? So a freehand and my triangle, right? So don't mind if it looking at the crack. Would ignore it. So this one is X, Y, Z. And let's say this angle here is 32 degrees. And we are given the length of the side as being 20 meters. And they say to find the length of X, Y. So, as I said before, in our solution, our step 1 is always, I'm going to write it a little differently now, right? Because you saw the steps. Step 1 is to write what you're given. So, this is what my solution would look like if I had an exam. I write given. I'll put, before I get to this point, you have to label the triangle, right? Don't forget that. Label your triangle first. So, away from the 90-degree angle is our hypotenuse. Away from the acute angle is the opposite. Underneath here is the adjacent. After label the triangle, then I could write what I given because I want to see that the hypotenuse is given, and that is the side YZ, and it's 20 meters long. I want to say I have the angle theta, which is 32 degrees. Next, I'm going to write what I have to find. I have to find XY, which is my opposite. My solution is to then write all of my formulas, and you're looking specifically at what you have in terms of the sides. I have a hypotenuse, and you also need to look at what you need to find. I need to find the opposite, because each of these formulas based on 2 sides. Either you have an opposite hypotenuse, adjacent hypotenuse, opposite adjacent. So anytime a question like this presents itself, you have to think about, okay, which 2 sides involved in the question, right? In a scenario like this where you're finding a side, one of them would be the side you're finding, in this case is the opposite, and the other side is the hypotenuse. So it means that I have to look for a formula that involves both opposite and hypotenuse. I can't use the others because this only have hypotenuse. I wouldn't be able to find for the opposite. This have the opposite, but it do have the hypotenuse. I have no information for the adjacent. So this is how you go about selecting which one of the ratios to use, right? So again, you're looking at what you're given and what you have to find in order to determine which one of the ratios you're going to use. Once you establish what you're using, right, use sine ratio. You put your formula. Sine theta is equal to opposite over hypotenuse. Then you start to plug in values now. So sine, you have the angle is 32 degrees. The opposite is what you're trying to find. That's the side XY. And the hypotenuse is 20. Now to work this out, it means that you are going to move to find XY. I have to move this 20 across the equal sign, right? If I had something like 16 is equal to x over 2. And I need to find the value of x. We will move the 2 across the equal sign and I'll get 16 multiplied by 2 is x. Same premise, nothing changing. Notice, however, though, that now that we're finding for the length of our side, I'm not going to be using sine inverse anymore. Now I actually have to work out what sine 32 is, multiply that by 20, and I'll get the length of xy. So I'm going to pull up the calculator. Right. So zero this off. Another thing too, when you're using a calculator for these type of questions, you have to make sure it's in degrees, right? You see it have DEG to the top here, that means degrees. If you see it in anything else, just hit the reset button, right? And it should take you back to degrees. So what we're doing, I'm doing open bracket sine 32. So the calculator knows to work out that first. When it work out that, I want it to multiply it by 20. Right? Easy like pie. Equals 10.59. You could put this to 2 decimal places. That would take us to what? 10.6. 10.6 meters to 2 decimal places. That's my value for xy. Everybody okay with that? More thumbs up if you're good with that. No large right with that. Children, you good? All right. So scenario 3. Now, once you do the 3 scenarios for sine, it's the same for the other functions, right? Scenario 3 now. We're finding another side. This time we're finding the hypotenuse. All right, so I'm going to draw a little diagram here. Say this angle is 43 degrees. This here is 10 meters. This is P, M, Q. And they want us to find the length of PQ. First thing first, label your triangle. Always label the triangle. If you're not sure, draw the arrows like I tell you. Don't be afraid to draw the arrows. An arrow away from the 90-degree angle will tell us where the hypotenuse is. The angle that you're given that you're going to be using, draw an arrow away from that, and that will identify your opposite. And the line that the angle is resting on is the adjacent. Cool? Right. Now you're writing what you're given. Given. We have the opposite, which is the side PM, and that's 10 meters. We have the angle theta, which is 43 degrees. That's all we have. What we need to find? We need to find the hypotenuse, which is PQ. We don't know that. So again, pay attention to the sides that involve. This is why these two lines are so important. This is how I learn it in school, and I keep teaching it the same way. It's important for you to know the two sides that you're operating with, what you have and what you want to find. Once you can identify those two, then you will know which formula to select. Now, these are the examples, so you know that I'm going to do sine. But in an exam question, you wouldn't know. You'll have to choose. So these steps will help you to narrow down your options in terms of which one you have to use, because this is where most students have the challenges, identifying. They say, sir, I don't know when to use sine, cosine, or tan. And I say, well, you have to follow the steps. You have to see what given, see what you have to find, and then choose a formula that have the items that you're looking to find and what you have. Because you can't work with what you have. Who's going to cook in the kitchen and decide they're going to make something? And they check the cupboard to see if they had the ingredients first. I should probably ask who's cooked first. Right? If you're going to cook something in the kitchen, you have to see what we have first. If we go and make our pilau, you have to make sure you have pigeon peas. You have to make sure you have your carrot, your rice, your coconut milk. You can't halfway into the pot and then realize it have no coconut milk. That will be problems. Right? So we have to see what we have first and what we're going to find. Everybody clear on that? So we know we're going to use sine because you have opposite, you have hypotenuse. Not this, not this. Quote the formula. Always quote your formulas. Write it down so that you're giving your brain less work to do. Right? Use sine ratio. If it's seeing it, it means that you can just watch and substitute the values now. So you write sine theta is equal to opposite over hypotenuse. Now that you're seeing this, you could easily see where you're substituting things. You're replacing this theta with a 43. You know the opposite is 10. The hypotenuse is PQ. Right. Now you want to find PQ, but PQ is in the denominator here. So just like we did before, you have to move this across on the side. You're not getting away from it. You have to move it across. So the sine 43 will be here. You will move the PQ on this side because it's dividing. When I come across, it has to multiply. 10 will remain here. But we want PQ alone. So this sine 43 can't stay there. We have to move the sine 43 across on this side. When we move it across, we'll have to divide. So now we'll go to our calculator. Zero this off. And check what we do now. We want to put 10 divided by open brackets, sine of 43. The brackets very important so that the calculator will work out what sine of 43 is first and then divide 10 by it. Then we hit equal. What we get there, then pay attention. 14.66. Right after two decimal places. Everybody all right with that? Give me a thumbs up if you're okay with that. Yeah? All right, so let's try some questions now. All right, so let's look at the solutions to these questions that we had for practice here. We had find angle ACB. So you want to find this angle here. Begin by labeling the triangle. This is our hypotenuse. This is going to be our opposite. And well, underneath here is our adjacent. We're going to write what we given. We given the opposite, which is 10 meters. That is the side AB as well. We given the hypotenuse, which is AC, is 17 meters. And what we require to find, we need to find angle ACB, which is the angle theta, right? We're going to use sine because we have opposite and hypotenuse. Use sine ratio. Going to write our formula. Sine theta is equal to opposite over hypotenuse. Sine theta is equal to 10 over 17. Theta is sine inverse of 10 over 17. .03 to two decimal places. And this is degrees, right? Number 2, same process again. Label. State what you have. State what you must find. Right? We know we need to use something that involves opposite and hypotenuse. So use sine theta is opposite over hypotenuse. Sine 39 degrees is equal to 16 over xz. Remember I said in terms of parameter cross. Now some students, they will do this part in there mentally. I, even as a teacher, tend to write all my steps. And it have a little reasoning behind that, right? Other than that's what my teacher used to make us do when I was your age and in school. And that habit remain with me. He had a valid reason, and I understand it more as a adult and a teacher now. One, it's easier for you to identify mistakes or to pick up on errors. And then when you practice doing things a particular way all the time, especially in these sequential steps, your chances for making errors is less. Apart from that, even if you do make an error, now we're teaching from the teacher perspective, now we're talking from the teacher perspective or marker, right? If you make an error and I am the examiner marking the paper, and this question is 5 marks, 4 marks, and we would have set that mark allocation based on the number of lines that we assume a student would need in order to work it out. If the last line is incorrect, I could still give you 4 out of the 5 marks or 3 out of the 5. I could still give you the majority and say, well, the student was on the right track. They just had a computational error, right? But if you're skipping lines and the answer wrong, or you're not doing any working at all and the answer wrong, then there's nothing left there for me to give any marks for, right? So this is why I suggest to always write maths in this sequential step-by-step way, right? This is what makes the difference between the one and the so-called distinction where you have A's in all profiles, because the examiner could see that thought process involved in answering the questions, right? So anyway, 16 divided by sine 39. Remember to put that sine 39 in brackets. I get in here 25.42. Don't forget unit of measurement, and it's our approximation, so write that to 2 decimal places. Right? Then we have this one here. So this one I deliberately changed the way the triangle is orientated, right? The orientation of the triangle in terms of which angle we find in, just so that you will practice doing this. This is your hypotenuse. This is now your opposite. This is your G-star. I hope everybody got that correct. So given the hypotenuse, which is KL, is 23 meters. The angle JKL 48 degrees. We want to find JL, which is the opposite. What sides is involved? Hypotenuse and opposite. So if hypotenuse and opposite is involved, it means that we're using sine. Yeah? So we use sine ratio. Sine theta is equal to opposite over hypotenuse. Sine of 48 degrees is equal to GL over 23. Move this across here, you're going to get sine 48 multiplied by 23 is equal to GL. $17.09. The 2 decimal places. Yeah, everybody okay with that? Right. So now for a wildcard question. I'm going to put a triangle up here, but I'm not telling you what ratio you have to use. I'm just going to ask you to find something for. I want you to use the same steps that I taught you to identify the difference. To first label the sides of the triangle, write what you're given, write what you must find. Then use that information to choose the appropriate formula. Because you went through the three scenarios for sine, cosine, and tan, if you have to use another one of the ratios, it's going to be the same thing. The only thing that will change is sine could be either, you will change the sine to cosine or tan. That's all that changes. Steps remains the same. Right? So I want you to apply what you learned to this triangle and find the length of AC for me. Everybody up for the challenge? So let's correct this and see how you did. So the steps that I told you guys to follow would begin with us first labeling the triangle. Arrow away from the right angle tells us where the hypotenuse is. Arrow away from the acute angle tells us where the opposite is. This means this will be our adjacent. Next, we write what we given. We given the hypotenuse, which is AB, and that's 17 meters. We also given the angle ACB, that is the theta, and that's 48 degrees. What must we find? We must find AC, and AC is the adjacent. So highlight or underline the sides that you're working with, adjacent and hypotenuse. You write the mnemonic I told you guys. So, ka, twa. I'm looking for one with a A and a H. This have the H, no A. A and H, just looking like it. A, no H. So we're using cosine ratio. All right, how many people got that? Write the formula. 17 is the opposite, yes. Sorry. My bad. Plus, you do hypotenuse just now. Go back writing hypotenuse. AB is the opposite, and I write opposite too, eh? That's tiredness, don't worry. Say teaching since 8:30 this morning. I still have one more to go. So, right, opposite. Good looking out. Appreciate that. Siobhan. Opposite. O and A. So, which one are we using? O and A is twa. Not this one, not this one, this one. So, we're using tan ratio. Yeah? So, tan theta is equal to my opposite over adjacent. Substituting values. Theta is 48 degrees. My opposite is 17. My adjacent is that side AC that they're asking us to find. We're moving this across on this side. I'm going to get AC multiplied by tan 48 is equal to 17. And then I'm moving this tan 48 on this side. So my calculator, don't forget to put that tan 48 in our bracket. 17 divided by tan 48. And I have for you 15.3068. So we could say that's 15.31 meters to 2 decimal places. Yeah? Everybody good with that? Monash, Jadon, yeah? Everybody get correct. Lovely. All right, guys.